the most powerful leaders of culture, business, and digital transformation. And I'm talking about Jim Vries and Hosni Adra, who are going to unleash digital twins on us to optimally empower the workplace. So Hosni and Jim have presented in several of our conferences before. They talk about very topics related to digital, business, and cultural transformation. And it's a real honor and privilege to have both of you back again, sharing your wisdom and expertise with our global audience today.
Thank you so much, Jose, for having us. We are honored to be here. We look forward to a fun and engaging discussion here on digital twins and sharing the great knowledge that Hosni has created over the years in spearheading digital twins. And Jose and Proqis, thank you so much for the opportunity to present. We're very humbled to be here. As Jose had mentioned, our webinar is focused on real-time digital twin to enable and optimize the workplace. So again, this is real-time digital twins. And so we'll just get started here. We all understand Industry 4.0, supply chain 4.0. It's all about digitizing the workplace. And the whole dilemma is how do you get all that data into a central location and then digitize it and make decisions. It's all about how do we make our decisions faster and better so that we can optimize our work planning. And as we know, in this VUCA world that we have, and we'll talk about VUCA in a minute in the first section, and talk about how dynamic this world is today. We're not in a linear world. Most ERPs are focused on linear S&OP. So we're talking about SOP and relating that to the workplace. Every employee is affected by the S&OP plan. If the S&OP plan is not working, people's lives are not good. So we're going to make that world a good world. And we're going to talk about the impediments. So we're in this VUCA landscape. What is VUCA? Volatility, uncertainty, complexity, and ambiguity. And it's through these things that are happening, especially in this COVID world of uncertainty and volatility, that we are really need something that can handle the nonlinearity of our supply chains. We have discrete events throughout the supply chain of getting things through, and it's optimizing these discrete events. And we would like to see it all nice and smooth, but in reality, it's this complexity of the many different nodes in your supply chain, the uncertainties, will you have it, will you not, and the ambiguity and how things are going to be changing. So this, from a supply chain perspective, this is all described within the bullwhip effect. So if you're a supply chain person, you all know about this. The bullwhip effect is the uncertainty caused from distorted information flowing up and down the supply chain. So what do we mean by that? From a demand perspective, a small perturbation and change in demand is going to create a very large amplitude impact at the supplier level. So it's a cascading from the customer, retailer, wholesaler, manufacturer, and supplier. That's what we're seeing here. Customer demand is changing dramatically. One day, cut me off. Next day, why can't you make enough? And then from a supplier perspective, we have these distortions. From the foundry, there's a lack of supply. We have geopolitical risks. We have, like in the Ukraine, with precious metals. All these types of upsets throughout the supply chain are causing us problems. We have all of our cargo containers in the wrong place at the wrong time. All these things are causing a supply issue, and it's cascading, and warehouses are overflowing, and yet we don't have what we need. And what we called, with the Supply Chain Risk Management Consortium, is the W recovery. So what do we mean by the W recovery? Is there's going to be lots and lots of ups and downs, and we've seen it since the beginning of COVID. We called it back in 2020 that we're going to be in this W recovery. So The question is, how do you deal with this? And the answer is a digital twin that is dynamic and is learning. And that's what Hosni will be getting into. And if you look at, again, the 101s of supply chain, you have the win for suppliers is aggregated and steadier supply requirements. That's what we want, but we don't have that now. The win for consumers is reliable availability. Again, we are having it pulling in that direction. So everything from supplier to stock and consumer to stock, those variabilities are going up and down, and you may be red, yellow, and green in different parts of your BOM, your bill of material, and it's what we need is how do we smooth this out, and that's what we get into with in a few minutes. But just at a high level, we all just to remind ourselves, you have the demand-driven operating model, which is at the operational level, the demand-driven, which is at the tactical level, and the adaptive S&OP, which is at the strategic level. So business parameters come in from the strategic level into the tactical level. You have your model configuration into your operational level. Then you look at your variance analysis coming back through, and then you're looking back into your check. So again, from actual demand on the left to market-driven innovation on the right, you're trying to find that balance. And again, we thank the Demand-Driven Institute for this chart. They are certainly the experts in this area. And so we move on into the second section, which is the data-driven digital twin overview and the 5 levels that we talk about: organize, standardize, visualize, stabilize, and optimize. And traditionally, going back 20, 30 years, this is the process that we all would follow, is how do we move through this process. And what we'll show you is a way to do this, not in 2, 3, 5 years, but how to do it in 3 to 4 months. And that's the big change that's happened. And why did it change? Because of data. Data is completely different today than it ever has been today in the past. And this is typical of most companies, is that most of the data is not trustworthy from a quality perspective. It's not integrated, and there's a lack of understanding. So can there be a platform to bring all this together? We just talked about IPPM, beautiful platform. These are all things that we need to do. We need to do enterprise information management. But what can we do now? All these things are 3-5-year programs, and they're all things that we need to be doing. But what can we do now to change the workplace today to help everyone on the floor? That's what we're going to talk about. So again, data drives information, drives knowledge, and then creates that intelligence, the ability to use artificial intelligence. We all talk about using AI, but if you don't have good data and you cannot turn that into believable information, then you don't have knowledge. And then using AI on top is not going to be worthwhile. So if you talk to any AI scientist, what do they spend all their time on? This first bucket, data. You have to get believable data so that the information is valuable to you, so you can use artificial intelligence. So number one roadblock, data. And in a recent webinar that we conducted, we asked the folks there what rank their concerns. And again, readiness for digital transformation, everything we're just talking about, data accessibility and availability. And then of course, the ROI story. So it always comes out on top on every survey that we've done. And that what brings us to the digital twins that Hosni will get into in the next few minutes. And I'm just going to kick it off with this slide that we put together. This is the new process. This is the new way of doing business, is look at it with the visual twin, digitize it, use supply demand optimization on stage 3, and optimize the workplace, and then create a sustainable process. So Hosni has, and Creatisoft has laid this out, where your benefits, as you can see on the bottom, can range up to 12, or from baseline of 12% up to 30% year-over-year savings with a sustainable process. So now I'll turn it over to Hosni, and he'll walk you through how this is is done with Creatisoft's solution. Hosni?
Thank you, Jim, and thank you everyone for joining us. So let me share my screen here and continue on a digital twin journey. So going from those points that Jim mentioned, you really have the 4 types of digital twins, and I'll go into each one in detail so you can see how that transitions all the way to the actual data-driven information that we would have. So starting with the visual twin, this is going to be the initial representations that you actually will have. That's going to give you kind of the view, basically the visual of how the operation is going to work. And then going from there, we're going to go into what we call our randomized twin. And randomized twin, we'll go into it in a bit of detail that kind of builds up on the visual twin and allows you to create that. What today has been done, pretty much on the simulation side and that type of section. From there, we're going to go into the data-driven twin, and that's where we're going to concentrate quite a bit on the data-driven and how that data is actually going to help identify and help us run more efficiently on a day-to-day basis going forward, transitioning then into that learning data-driven twin that is actually a shadow twin of the operation, and it's constantly integrated with everything else that you have within the system itself, going from the system to the worker as one continuous operation. So if we look into each one separately, you look at the visual representation, and again, these could be just purely visuals of what the twin is going to look like. It's going to show you the people moving. It looks cool. It's great. But it really doesn't give you any more than that. It's just a way to show you that this is how the operation is going to eventually look like. The only benefit that you get out of that is as you're building it and as you're putting that visual, you're kind of going through slightly over the processes to say, is there a better way to run it? Or, that's what we're doing today. So you're kind of just building that knowledge of all these intricacies of what happens within the operation itself. So it's very, it's visual. It shows you detail. You can show bottlenecks, but they're really made up bottlenecks because you're creating them from the visual aspect of it only, not from the actual analytical aspect of that twin. So it really has no analysis value. You cannot deduce any representation out of it, and it's really going to give you a basic flow representation, but that's where it ends. So what we need to do is actually extend that and go more to the next phase where you actually do the randomized twin. And then the randomized twin, there is minimum requirement operation that you would have. You actually will put in a random data on what actually happened within the operation. It just builds on that randomness that you have to kind of identify what potential issues that could exist within the operation itself. It doesn't have all the visual constraints, but at the same time, it doesn't have all of the analysis that we need going forward. So from that point, it's really going to give you an overview of what the operation is going to look like. So you'll be able to see how kind of different systems interact, how different equipment interact. It's going to give you that idea of, this is my boundary. This is as fast as I can run today, or this is as slow as I can run. I can have 50 items in my whip at any point in time, but these are just boundaries that you kind of stay within those conditions. And then you go into the iterations as you create those since it's based on that randomization of the data, you actually will have to start running Monte Carlo simulations. And if you've done Monte Carlos, back in the 90s and early 2000s, Monte Carlo was like the holy grail of simulation. Everybody was doing it. Every time you do simulation with randomization, you have to run the Monte Carlo to make sure that you're conforming. Now, a lot of things have changed since then, and That's really what the transition we're going to do when we transition to that data-driven model instead of the randomized model. So from a sample scenario, just to give you an example, this will apply to a warehouse. It will apply to the supply chain on the outside, to outside the four walls, inside the four walls. It'll apply to any type of manufacturing, whether it's a high mix, low volume, high mix, high volume, or anything in between. The key is you need to know where your material are at any point in time, and you need to know if it's going to have any impact on your operation. So if you want a set of material to be at a specific station at a point in time, you need to know where that material is and how it's going to transition. If it doesn't get there, then you're creating inefficiencies within the operation. So what we're doing there is kind of trying to figure out ways to eliminate that and kind of give you that visibility into the operation and use that visibility to figure out how you can run better and how you can optimize and improve the overall flow of the system itself. So that's also going to tie into the people, right? It's not just all about materials, but it's going to go through the material handling process. It's going to go over the actual process itself and how the workers interact with the different systems. So from there, you go into the analysis of a randomized twin, and as you look into the randomized results from the twin, you will realize that scheduling is an issue. You would realize that you don't have enough people, or you're not your workforce is not cross-trained, or different constraints there. But you really cannot optimize that because you're optimizing random data, and optimizing random data is going to really not give you the results that you need. So even with a Monte Carlo analysis, you really get into that 90% accuracy ratio, which is really where you want to be if you want to run in that real time and constantly adapting and figuring out what's actually going on within the system itself. So going from there, we kind of tie into the data-driven digital twin, which really is driven by your data set. The key there is instead of putting in random data into the twin, you're actually feeding it data that you have within the operation itself. Now, the transactional data that you're feeding in doesn't have to come in from one place. You might have an ERP system that has some data. You will have an RTLS system that's generating a different set of data. You have a system that's running your material handling that's got data. You've got your HR that has data. All that is coming together, and it's going to go into that digital twin that is driven by those different data sources that are coming in. It's creating that view that actually represents what's happening within the operation. It's not making a randomized view, it's making an actual view, a true view of what the operation looks like, and you can see it basically on the virtual representation through the digital twin. So historical data, again, it could be machine schedules, it could be your maintenance, depending on your operation. If you have a lot of changeovers, if you have a lot of cleaning or CIPs that you have to do on a continuous flow type operation. But really what that's going to give you is a guide to what that cost to serve this queue is going to be within the operation itself. And it's going to give you a way to get to that point in not just on the virtual implementation, but on the actual implementation on the flow by using the different optimization techniques that are inside that digital twin. So then you start to achieve that relationship of this is where I need to be from a cost to serve perspective of this queue, and this is where I'm at, and it's going to give you the steps to actually get to that point. Now, the key is if you stop there, then you risk actually going backward in that cost to serve this queue going forward. Your operation is dynamic; it's not a static implementation. Things change. You have seasonality. You have external conditions, as Jim mentioned, that actually impact the overall flow. So you cannot just use that as say, I optimized today and I'm good. I'm just going to let it be for the next 2 years, and I will revisit that when the time comes. The other thing is if you don't tie it into the actual workforce and to the worker itself, then you're not creating that sustainability going forward. So they have to understand why that change is being made, and they have to be driven by the actual system to perform that change. So you do actually get a lot more accurate results from that data-driven twin, and the accuracy results from the 100+ operations that we have done so far is we're looking at 99% accuracy from a model perspective, from a digital twin analysis and representation, whether how it represents current state or how he's tracking forward by analyzing future state and how that plays out. So at 99% accuracy, I can say I can really optimize this one. I can get a real benefit out of the system and get that optimization that I need going forward. So so from a benefit perspective, you're going to get all the detail on the data-driven twin. A lot of people are going to do value stream mapping, and they will do a state and time of what the value stream is going to look like. Well, if you look at the data coming from the data-driven twin, you can actually create a value stream map that is as dynamic as your operation. So your value stream will change, your efficiencies will change, your cost will change, and you'll be able to see that live through time, and you'll be able to see how those impacts are actually going through. Any operation changes, you'll be able to actually see it and analyze it to a high degree of accuracy going forward through that data-driven twin, of course. Now, the only downside to this is it's not going to learn, and it doesn't have that capability to actually touch the worker. So it doesn't have the ability to go back and tell the worker what to do, or what the next move is, or what kind of operation it needs to perform. All it'll do is it'll tell the people who are running it to say that this is your data-driven, and that's how your operation could improve and get to that cost to serve the SKU is. So from that point, we go into really the main thing. The main topic is that real-time data-driven twin. And real-time data-driven twin a lot of times could be viewed as just it could be a shadow twin that's actually going to give you that representation of what's happening within the operation, and it's also going to give you that real-time learning aspect of understanding what's happening within the operation and consistently looking at ways to optimize and improve the overall system. The key thing to it is everything in it is dynamic. So if your operation changes, the learning twin is going to know about the changes, and it's going to start to create that impact, and it'll start to actually transition the optimization toward that change. So if you have a scheduling system, for example, and the trucks didn't arrive at 3 a.m. the way they're supposed to, they arrive at 5 a.m. So the scheduler at that point in the current system is going to be struggling to figure out how to make the systems work based on that delay. Well, the learning data-driven twin already understands how your operation works. So it can take that data change, which is the delay in arrival, and it will work it into the system so you can have the actual optimized state automatically running your operation in real time. And that's the advantages of that of the real-time twin going forward. So you actually get into an implementation where you have the visuals, you have the ability to actually do analysis, because as it's collecting all that data, you can actually do a replay of anything that happened in the past. If I want to see what happened last week, I can actually look at it in a high-speed mode through my data visualizer and see the animation of my operation based on that. I can use that for offline analysis, and at the same time, I can use that to learn and understand how the actual operation will work going forward. That's where those systems really become very empowered and very powerful in the way they operate. So really, the way that from a connectivity point of view, and what has been done so far from a connectivity perspective, is you've got your systems that are running the operation, whether it's SAP, ERP, WMSs, or any other things that you have. You have the equipment itself that is running based on PLC, and you have controls that are actually being returned from that. In some cases, you might have some custom things that you would use. RTLS is huge. RTLS could mean static or active RFID tags. It could be GPS. It could be data coming in from your material handling system, identifying where your automated guided vehicles are and how they're actually progressing, and what efficiencies they're actually, what their battery charge are, for example, at any point in time. Of course, you tie into that other systems that are tracking the different components that run the operation. So if you have, as an example, if you're tracking your tooling, you can use the Wiser system as a way that will track the tooling and then can feed into that digital twin, and will help you identify how you're utilizing your tooling and how to improve and maximize the cost of, or actually minimize the cost of running the operation, right? Then you add to this all of the natural way, or the actual motions of doing the task. Any repetitive task is going to have an efficiency degradation through time, and you'll be able to see how that efficiency is actually going to degrade as you use more, as the operation actually progresses. So based on that, we actually feed kind of all of these different components into the data twin. All the BOM, the system constraint, it doesn't matter how detailed it is, you actually need to get that data in, and that's going to be kind of the driver of what's going on. Current state data, that actually is a comparison between what the digital twin thinks is happening today and what the digital twin actually is going to have, is happening in real life. So that comparison is going to help it identify those variations and fine-tune the optimizer in order to identify those things. Scheduled maintenance for sure. Historical data, people ask how much historical data do I need? And there is really no limit on how much historical data you have. The more you have, the better it's going to be, the better it's going to learn. The less you have, the longer time it'll take to achieve that steady state of constantly providing improvement within the operation. So based on all these components, you actually will get that all the insights, all of the views of what's actually happening within the operation, and it will allow you to move forward in identifying those constraints. So historically, that optimization has been happening about every 15 minutes. You can run it every minute if you want. It depends on how dynamic the operation is. In a warehouse, you probably will run it every hour. It all depends. If you have a highly automated system, then you might actually need to run it a bit faster in order to keep that operation going. But that's something that you can control from the controls of the system. You can optimize your schedules, as I mentioned. Any delays, you would actually know ahead of time. You could send you alerts. People would ask, well, how would I know that I'm going to have a problem 2 hours from now? And it can be as obnoxious as you want it to be. It can text you, email you, call you. It will let you know. If you only want to use one of those, then you can basically pick one of them. The accuracy of the system is very high. It's using actual data. It's performing the same representation of your flow. It's a true representation of your operation, except in a digital form. So from that point, you really get to that 99.99% accuracy in the way that digital twin operates. That's going to give you that extra confidence in the way it works when you show it to your workers, and everybody who's going to be involved in the operation. They actually will see the operation running live the way they see it in the true environment. So there is no question there of credibility to say your digital twin is not running my plant, or is not running the same way as the warehouse. The key to all this is we actually use a set of neural networks in the background. Those neural networks are automatically learning from every single data point that comes in, and they are going to help in optimizing going forward and providing a forecasting method into what's going to happen into the operation in the future. That's really the base of the optimization. There's a lot of optimization that actually happens within the operation itself, that's outside of the neural network, but really the network is what's going to give you that AI capability to be able to see how things are going to change going forward, and how you're going to keep them optimized. Now, I did mention that it needs to touch the worker. So this is a kind of a sample screens that were set up on an actual implementation, where you can see, based on the operation itself, what the worker is doing, and it's going to guide the worker. So this is all real time. This is not something that happens 10 minutes ago. So as the worker is actually going in and putting a pallet on a rack location, it's automatically telling them, you need to put this pallet, and it's going to go at location, the NF27B. So that NF27B now is kind of a control point. As the worker is moving around the warehouse, they will guide them to the location, and as they're going through, when the actual forks get close to that location, that bar is actually going to turn green to say that's where you need to go. And then based on that, they will unload the pallet, and as soon as the pallet is unloaded, there's a check to make sure that that actually happened. And the worker doesn't get another task until that task is completed and is successfully completed the way it needs to be. So now it's actually going down and guiding the worker into everything that they need to do, and then going forward to the next step. So if they need to go on break, they just mark it that they're going to be on break, and they will not get additional missions. If they are not on break and they're working, it's going to tell them what the next mission is. It's not up to the person, to the fork truck driver, to figure out what to do. It's up to the system to tell them what's the most optimum move they need to do next in order to make the operation more efficient. And that's really how it guides the overall operation. Now, same environment will happen with tooling. Okay, if you have your tooling operation, if your tooling control basically based on the Wiser system, that SpinWiser is going to go in and identify how much tooling you're going to use for each component. That can feed into the data-driven twin. Now you can track your consumables along with the rest of the operation, and your cost to serve this queue is now built in the consumables that you would use, and you can track that as reports to identify how well your consumables are being used, when do you need to reorder, and all the different components for that. But the key for all this stuff to work is you need to have the right workforce to actually make it do what you need it to do. And that's where actually that predictive index allow you to get the true work environment and the true workforce to actually do what you need. And Jim, do you want to touch on the predictive index and how that applies?
Sure. You know, change management, we always believe in people, process, data, and technology. So it'd be amiss if we did not take into account the importance of people, because of course, if the frontline workers and management aren't aligned to this transformation, it's going to fail and it won't sustain itself. So it's very important from the very beginning is to understand the makeup of your people, who they are, what they want to do, and so forth. One of the best tools out there, being a change management expert for over 20 years, I found that, people really don't know who they are, may not know who they are and what they want to be. And certainly management, everybody has preconceived notions of who each other are. And one of the coolest tools out there today is called the Predictive Index. And you can kind of click through these next 4 builds. And what they do is you take a survey, it takes you less than 5 minutes. Go ahead and click, Hosni. And it puts you through a set of questions in 5 minutes, and you will be assessed as to be a collaborator, a promoter, a maverick, exploring in that right quadrant, or you're stabilizer, or you're an operator, or a guardian, or a craftsman, or you're producing a scholar, controller, or strategist. So these are all the personas that you have. And if you click one more time, there's some personas in the middle that are the flexors, the individualist, altruist, and adaptive. There's no right or wrong here. It's just who you are. And to get the job done at the beginning of the job, you may need more exploring type people, but in order to get it stabilized, you need people that are operators, guardians. And the cool thing is, if everybody on the team, from the front line to the frontline management to leadership, know who they are, we can, cultivate these natural behavior types to synergize your team around getting the job done and making sure that we have the right people at the right place to help and enable this type of transition. This is a huge transition we're talking about. We can do it we can do it faster. The number one issue on speed of implementation is this. It's not the technology. It's not collecting the data even. So you got people, process, data, technology. The process is captured because we have the data, and we're like Hosni said, we're doing the end-to-end value streams in real time. So we've solved those problems. At the end of the day, it's always going to come down to people and understanding the people to make it work. So Hosni, back to you.
Thank you, Jim. So going from that point, you actually will look at some of the data that you can do. And this data, you can customize this to any way you want. That's kind of a sample that we pulled out from an existing system, but that changed. The key there is the data is not something that happened yesterday. It's not your historicals. It's actually what's happening now within the operation and how it's going to change going forward. So that's really the advantages there. Now, the main thing about this whole setup is you're actually able to go from 0 to full implementation in 3 to 4 months. You don't need to wait 3 years to get it done. You can actually get it done very quickly and start to benefit from there. The one thing to keep in mind is if you stop right after the data-driven twin, you don't do that transition to the real-time, then you will miss on a lot of opportunities on actually getting that extra 2 to 5% benefit of going through the real-time optimization and maintaining the optimization that you've done. It's more of a curve that if you stop optimizing, your data is going to change, your environment is going to change, and then your actual benefit will start to degrade through time. So that real time will make sure that it stays on an uptick curve all the way as you're going through the operation itself. Jim?
Yeah, and just to close it out, again, we do have a roadmap, proven roadmap of over 100 clients going through this process in this 9-month program that we just laid out, but we really want to open it up for Q&A for Jose to come back, and we'll try to take as many questions as we can.
Outstanding, Jim, and outstanding, Hosni. Though, what a great masterclass on the latest when it comes to digital twins. So I'm gonna ask you, Hosni, if you can stop showing your presentation screen so we can bring our cameras in bigger format for the audience. You just go there and yeah, hit that button. Well done. And so, gentlemen, what great coverage on all these different stages. One of the first questions that I have here in discussions from the audience has to do with the stages themselves. Are you suggesting that organizations go through stage 1, 2, 3, all the way to 5, or you're suggesting that actually you can go directly to a different stage, maybe stage 5, or is this a more of an ascending process here to get there?
Yes, the key there is you have to start. You can start. If you already have some kind of a data-driven digital twin, then you can use that as a springboard. If you don't have that, then the data-driven digital twin is where to start. That's really the main thing. You don't want to start on the visualization side. You really want to start in a data-driven digital twin, and you actually will start to see ROI after the initial 4 weeks of the implementation once you do that.
And if I could just add, I think you can start as fast as you want to go, right, Hosni? But
that's correct.
If your culture has to see before, if that's their crawl, you may have to look at it and do the visual first, because that's what your culture can handle. It's all what your culture can handle on what stages and how fast you go through. It's really up to you and your organization. I would just and add to that. But you can start as fast as a data-driven, like Hosni said. Is that right, Hosni? Is that a good summary?
Yep, that's exactly right.
So when you're looking at operations, what does the target operation, maybe a client for you, may look like? Someone who is maybe the best cases, either from a operational dynamic standpoint, or maybe from a cultural perspective, maturity perspective. Are you looking at high volume manufacturers, low volume, high cost manufacturers? What does the target client looks like for you?
That's an excellent question. Actually, the target client is anyone who wants to run the operation better. It can apply to anybody. It can apply to the high mix, to the low mix. It can apply to the warehouse, small and big. But the bottom line is, if you want to run more efficiently, then you have to go that route. We can't anymore rely on just one or two people running the operation. We have to make sure it is self-reliant and it runs basically independently of anybody touching any buttons. And that's really what that real-time data-driven twin will allow you to get to. So again, if you want to improve, then that's really the way to go.
And it's also, how far do you want to go? Do you want a totally automated warehouse where there's no people? I mean, if you want that, we can build that. But if you want people in there, then the ROI is going to be different, right? And the higher the mix, obviously the ROI will come faster. The more complex, the ROI comes faster. But in a make-to-order environment, you can still gain a lot from using this tool. So you're going to gain no matter what. And with the VUCA world, can you really afford to be slower than your nearest competitor? You need to be faster than your nearest competitor, and this is going to ensure that you are.
What do you find to be the biggest barrier to implementing that across the clients that you have? Is it technology? Is the data availability? It's just the people resisting new ways of thinking? What tends to be the biggest challenges for people who are embarking on this journey?
A lot of it is culture, is just believing in the technology and accepting it within the organization. That's why they need to actually see it and believe it to go from that data driven to the real time. That's always a roadblock from that point. Data availability is another control. It's a lot of time controlled by IT. You cannot get access to the data, so that needs to be enabled. Again, the systems are reading data, they're not writing data back. So it really has low impact on what's happening within the operation itself. Those are kind of the key roadblocks. Then it goes, from, that not being able to spend the time to actually get that digital twin up and running. And we can also help with that in those conditions.
You can do this, Hosni, right, without disrupting production. So you don't have to shut. I think that's really key.
Absolutely. Everything can be running in the way it is, and you can actually roll it out with zero downtime.
Yeah, there's so many aspects of what you have talked about here that are incredibly valuable. Variable demand alone is something that most operations are not set up to do well, and that's just one aspect of it. And as you know very well, the issue of variable demand and supply has created all sorts of disruptions on current workflows. And what you have here is you address the basics and you take it to very advanced levels of intelligence and cognitive approaches to optimizing flow. There are leading approaches across this industry. So Thank you so much for sharing this great presentation, so much content and value here, and thanks for leading the way on such an advanced digital transformation approach.
Thanks for having us.
Thank you.
Ladies and gentlemen, Jim Vries and Hosni Adra, as I mentioned for the setup of the session, these are great cross-industry leaders and practitioners who are implementing meaningful digital transformations. A lot of people talk about smart factory, and it sounds good in a PowerPoint presentation, but it's really hard to implement. And when you are doing that type of implementation, that level of digital transformation, you want to have leaders like Jim and Hosni behind you, because they have done this for a few decades, and they have the technical and the organizational capabilities to make something this a reality. Some of the most advanced approaches for variable demand and supply, and optimization of flow and value creation in operations. So terrific masterclass level presentation here. Did a very good job and really summarizing what is very complex concepts in a 35-40 minute talk here. So thank you, Jim, and thank you, Hosni, again for your industry leadership. We are going to be taking a break now, and then we come back. We are going to bring you another great industry leader of culture, business, and digital transformation. So at the top of the hour, we are going to meet Raja Gangavarapu, who is the Enterprise Vice President of Software Engineering at Wolters Kluwer, and he's going to talk to us about the employee as a customer, our professionals as customers, and digital employee engagement. So I will see you with Raja at the top of the hour.